Hi, this is David. Welcome to a video review for Meissner's Correlation Risk Modeling and Management. This video is a review of his Chapter 4, and this is the last chapter assigned in the sequence under Part 2, Topic 5, Market Risk for Meissner. This is a chapter about Copulas, basically, and its title is Financial Correlation Modeling, Bottom-Up Approaches, where the idea is here in Chapter 4, we're overcoming the theme really is an overcoming of the limitations of those traditional metrics that he reviewed in prior chapters, especially the Pearson's correlation coefficient, or just the correlation. Recall that is a measure of linear dependence with associated limitations. So we also had measures of rank correlation. However, those are also have their own limitations. So this Chapter 4, the way that I would view it is, it's an overcoming of those limitations with the profoundly flexible Copula model, and where there are many different choices, and the general cost of that, the price of that profound flexibility, is the complexity and perhaps the model risk and some of the fragility of the assumptions that we'll see. So the Copula does not refer to any particular type of function. We'll see that it's profoundly, almost infinitely flexible. However, it tends to be associated, for better or worse, with the infamous, at this point, Gaussian Copula. And so the Gaussian Copula is just one flavor, the most famous flavor or version of a Copula equation itself, which is very flexible. So we have explained the purpose of the Copula function and the translation of the Copula equation. Second, describe the Gaussian Copula in particular and explained how to use it to derive the joint probability of default of two assets. And third, summarize the process of finding the default time of an asset correlated to all of the assets in a portfolio using the Gaussian Copula. So here, first is general Copula equation, second is the specific Gaussian Copula, and third is the application of the Gaussian Copula to estimating the default time. And now we do have a learning XLS associated with this, and it's a blend, a combination largely of Meissner's own spreadsheets, and then a few that I have generated and included as well. And so that learning spreadsheet does have a working model of a Gaussian Copula, or specifically really a bivariate normal distribution. So you can look at a working example of a really common application of the Gaussian Copula in the learning spreadsheet. So Copula functions are designed to simplify statistical problems. They allow the joining of multiple univariate distributions to a single multivariate distribution. A Copula function C transforms an n-dimensional function on the interval 0 to 1 into a unit dimensional one. So that's the first job of a Copula function, is that it's simplifying a statistical problem.